First, let's start with pairs. Pairs provide us a way to store two objects as a single unit, as a tuplet. To access the elements in a pair, we write pair name dot first to access the first value in the pair and pair name dot second to access the second element of the pair. We declare the pair as pair less than data type 1, comma data type 2 greater than pair name. Here in the pair name, it stores two values in which first value will be of data type 1 and second value will be of data type 2. The data types can be char, int, a float, string, and anything, etc. There are different ways to initialize a pair. One such way is to initialize while declaring it. As we seen before, this is the way we declare a pair. We can just write an open bracket value 1 and value 2 to give the values to this pair. Example, pair less than int comma char greater than p1 comma a. Now this pair p will store two values 1 and a. The second way of initializing it is by using giving values separately, like pair underscore name dot first equals to value 1 and pair name dot second is equals to value 2. For example, to initialize a pair P which contains the value 1 and 2, we can write it as P dot first equals to 1 and P dot second is equals to 2. And the third way of initializing a pair is by using a make underscore pair function. You can just write a pair name equals to make underscore pair value 1 and value 2. Now here, pair P stores two values, which is value 1 is of type integer and value 2 is of type character. To make P store 1 comma a, we can directly write P equals to make pair 1 comma a. Fourth way of initializing a pair is writing like pair equals to value 1 and value 2 in a flower brackets. Like P equals to 1 comma a in flower brackets. Fifth way, if we write pair P2 of P1, P2 will store the values contained in P1. Now in this example, P2 will store 1 comma a. So P2 first will be 1 and P2 second will be a. If a pair is not initialized, it stores the values of default values. So here pair less than int comma char greater than p is not initialized. So p dot first will give 0 as 0 is the default value of an integer. And p dot second is null as default value of char is null. Similarly, the default value of double is 0 and string is null. So p1 dot first will be 0 and p1 dot second will be null. If we say that two pairs are of same type, if data type 1 of both are same and data type 2 of both are also same, we can swap two pairs of same data type by just writing pair1 dot swap pair2. Here is the question. You can just scan this QR code to answer it. So as we know the default value of int is 0 and default value of string is null, p dot first will be 0, p dot second will be null, but null will not get printed. So the answer will be only 0. Next, we know that we can compare two integers by using equals to, greater than, less than, greater than or equals to, and less than or equals to. Similarly, we can compare two pairs of same data type. Equals to operator checks whether pair 1 first is equals to pair 2 first and pair 1 second is equals to pair 2 second. If both these conditions are true, it returns 1. If not, it returns 0. And any other operator in pairs, it first checks the first element in both the pairs. If pair 1 first and pair 2 first are equal, then only it checks the second values in both the pairs. Not equal to, it first checks pair 1 first and pair 2 first. If they are not equal, it directly returns 1. But if they are equal, it checks the second values. If both are equal, then it returns 0. If both are not equal, then it returns 1. Similarly, less than, greater than, less than or equals to, and greater than or equals to, they return 0 or 1 by first comparing the first values of the pair, and only if the first values are same, they check the second values of the pairs. Now here in this code, P1 is equals to P2. The first value of P1 is 10 and the first value of P2 is 9. As both are not equal, it directly gives the output 0 without checking the second values. Similarly, P1 greater than or equals to P2. As 10 is greater than or equals to 9, it directly gives the output 1 without checking the second values like 11 and 12. In the case of P3 and P4, the first values are same. So now it checks the second values. As ASCII values of A is less than ASCII value of B, it returns 1. And A is different, A is not equals to B, so it also gives the output as 1. Next, we move on to stacks. Stack is a data structure in which elements are stored as a list and elements are added or removed only from the top of the stack. You can think a stack as a pile of books placed on a table. The last book which you kept on the top is the first book which you removed. So they are also called as last in, first out. And stacks are declared as stack less than data type greater than stack name. The data type can be int, string, float, char, and etc. Example, stack less than int greater than st. Now st is a stack which stores a list of integers. And some of the useful functions which we use in stacks as empty function. It checks whether the stack is empty or not. If it is empty, it returns 1. If not, it returns 0. Size function, it returns the size of the stack. Top function, it returns the reference to the topmost element present in the stack. Push function is used to add elements to the stack. As elements are added from the top of the stack, this element G gets added at the top of the stack. Pop function is used to remove the element. As the elements are removed from the top, so it deletes the most recent entered element, that is top element of the stack. All these functions have a time complexity of order 1. You can scan QR code to answer this question. Just go through the code and analyze it, then answer it. Yeah, most of you answered it correct. As the push function adds the numbers on the top of the stack, the numbers will be stored like this. And when you, while 12th line is executed, first 0 gets popped out, next 25 gets popped out, then 24 gets popped out. So you're left with 22 and 21. This function, this loop allows us to print the elements present in the stack, that is 22 and 21. Next, we move on to queues. In this data structure, it is similar to stacks, but here elements are inserted from one end and removed from the other end. That is, the elements are inserted from the back side and the elements are removed from the front. You can think it as a queue in a bank or ATM, where the first person entered and is the first person to leave. So it is first in, first out. Stacks are last in and first out. And to declare a queue, we write queue less than data type greater than queue underscore name. The data type can be int, string, char, and etc. Queue less than int greater than queue. This queue stores a list of integers. And some of the useful functions in queues are empty. It checks whether queue is empty or not. If it is empty, it returns 1. If not, it returns 0. Size function, it returns the size of the queue. Push G, it adds the element G at the end of the queue. Pop deletes the first element of the queue. Front, it returns the reference to the first element of the queue. And back, it returns the reference to the last element of the queue. The time complexity of all these functions is order 1. There is one other function swap, in which if two queues are of same data type, that is data type of both are same, then we can, by using this function, we can swap the two queues. Like, try to analyze this code by yourself. Here we declared a queue Q1 and we inserted the elements 1, 2, 3. First 1 is added and 2 is added to the end of the queue and 3 is added to the end of the queue. Now we used a function print queue. This loop helps us to print the queue. Like first, it checks if the queue is empty or not. As it contains the elements 1, 2, 3, it's not empty. It prints the front element, that is 1. And then it pops the element, so 1 gets removed. Now queue contains 2 and 3. And still the queue is not empty. And then it prints the first element. Now the first element will be 2, as 1 is already removed. So 2 gets printed, then 2 gets popped out. Next we have an element 3, so the queue is still not empty. Now 3 gets printed and 3 gets popped out. Now the queue is empty, so we come out of the loop. So this prints 1, 2, 3. Next, we initialized a queue Q2. Similarly, we gave the values 4, 5, 6 to the queue. In a similar way, it prints the elements 4, 5, 6. Now we use the function swap, Q1 swap Q2. Both are of same data type integers, so Q1 gets swapped with Q2. So now Q1 will contain the elements 4, 5, 6 and Q2 will contain the elements 1, 2, 3. So when 27th line gets executed, it gives us 4, 5, 6. And when 28th is executed, it gives us 1, 2, 3. And here it is given that cout q1 dot empty. As q1 is not empty, it contains 4, 5, 6. It output 0. Next, we move on to deques. Deque is a special type of queue where insertion and deletion operations happen from both sides. Deque is nothing but double-ended queues. They are similar to vectors but are more efficient in case of insertion and deletion of elements. Many functions that we use in vectors can also be used in deques. Deques is a superset of stacks, queues, and vectors. And in stacks and queues, we cannot iterate from one element to other. We can just add and remove the elements which are on the top. But in deques, we can iterate over all the elements present in it. And the useful functions present in deques are push front x. It pushes the element x to the front of queue. In queues, we just have push and pop function, but here we have push front and push back, as we can add the elements from the front and also from the back. So push underscore front x, it adds the element x to the front of the deque. Push underscore back x, it adds the element x to the back of the deque. A pop, in the similar way, pop can also be done from either side of the deque. So pop underscore front, it removes the element that is present at the front of the deque, and pop underscore back, it removes the element at the back of the deque. Front, it returns the reference to the first element of the deque, and back, it returns the reference of the last element of the deque. A size, it returns the size of the deque. There is one other function like maximum size, which returns the maximum capacity, like maximum number of elements that can be stored in the deque. Empty, it checks whether deque is empty or not. If it is empty, it returns 0. Oh, sorry, it returns 1. If it is not, it returns 0. Try analyzing this code. In this code, I declare Deque, which stores a list of integers. Pushback Deque.pushback 10 is stored in Deque. Deque.pushback 20 is stored in the front side. So 20, then 10. Then Deque.pushback 30 is stored in the back side. So 30 will be added here. And Deque.pushFront 15 will be added to the front side. Show Deque is the function here. As I said before, in dequeues we can iterate over the elements, which we cannot do in stacks and queues. ITR is an iterator which iterates through elements in this deque. First, it starts with g.begin. That is, the iterator will point to 15. Cout star ITR, it will print 15. Then it points to 20. It prints 20. Then again it points to 10. It prints 10. Then it points to 30 and it prints 30. So we get output 15, 20, 10, 30 with the 16th line present here. Deque.size gives us the size of the deque, which is 4, as we have 4 elements here. Deque.add2. This is a function like which we used in vectors or arrays. As deques are very much similar to the vectors, all the functions in vectors can also be applied in deques. So Deque.add2 will give the element present at second index. This is 0, 1, and 2. So Deque.add2 will give us 10. Deque.front will give the as front, it gives the iterator reference to the front element. The front element is 15. So Deque.front will give us 15. And Deque.back will give us 30. Deque.popFront. As we know, pop front element removes the front element present in the deque. So 15 gets removed. Now, similar to here, the show deque prints the elements present in the deque, that is 20, 10, and 30. Now we remove the last element as we wrote pop underscore back. So it removes the last element. Now 30 gets removed. So we are left with 20 and 10. So show deque, this will give the elements present in the deque, that is 20 and 10. That's all from my side. Apur will continue with the rest of the session. If you have any doubts, you can ask in chat or also in Slido.
Is my screen visible? Okay, guys. Hello, everyone. Good evening. I am Apur, a coordinator of Programming Club IITM. And the topic which I'm going to take today is, as you can see, sets, matrices, and unordered sets as well as multisets. I believe these topics are actually very easy, but very important also. So when this topic was first assigned to me, I thought like, okay, sets is a type of container. It is indeed important, but why is matrices also important? I pondered upon it, and then I found after giving various contests that actually it is very important topic. Like if you have given even 2-3 topics, I believe you would have come across at least one question of matrix. So considering it as a separate topic, isn't it worthwhile? So that's how important matrix is, even though it might not be considered as a separate concept as such, but I believe it's also very important. So let's start. This is the Slido link, which will also be shared in the group, WhatsApp group. And let's start. So what is a matrix? First of all, the question comes, what is a matrix? Like many of you would already know what is a matrix. So basically it is an arrangement of elements in rows and columns. As you can see in this picture, uh, there are m rows and n columns. Very simple. Now, whenever we define a matrix, we need two variables. One is number of rows and one is number of columns. Here in this case, m is number of rows and n is number of columns. So the next question is, how do we declare a matrix? So it's actually a 2D array. Like whenever we consider a matrix in coding in general, we consider it as a 2D container. Now by 2D container, I mean it can either be a 2D array, it can be 2D vector, it can be 2D of anything. Generally, it is defined as a 2D array. Like in this case, I've defined it as a 2D array. So as you can see, I've initialized it like this: int matrix 3 3. What are both these three here? The first three is a number of rows. The other three is a number of columns. So let us analyze this line. Int matrix 3 3. Int data type. Now what does int here signify? It means that whatever the elements in the matrix are, these are all of the data type integers. The name matrix I've given, you can give any name which you want. You can give your name. I can give my name like int apur 3 3, anything. So this is one of the most common way to define it. Next, how can we initialize it? Like we already know what the contents are and we want to initialize it. So this is the way in which we can initialize it. So the same as the previous one, int and variable name. In this case, I have taken mat, number of rows, number of columns, and then we initialize it in curly braces. So in braces here, there's one bigger brace and then it's smaller braces. Now what does each brace signify? Now each brace here defines the rows. Like here 2025 is the first row, 2224 is the second row, 1822 third row, 1724 fourth row. Now the question comes, what if we want to define it column wise? So basically there is no predefined way of like defining it as a column wise. There's only one way we can initialize it, by the rows. That's by definition. Now suppose we don't want to give this small curly braces. If we skip it, what will happen? Now this is given in the second part of the slide, wherein the curly braces, the smaller curly braces are not given. Now in this case, what does the C++ compiler do? It uh, counts it, like for example in this case it considers what are the number of columns, and after every column it separates the rows. Like for 2025 this is two elements, so this is the first row, 2224 second row, like that. Next, now what if we don't mention the number of rows? Is it fine? An answer is yes, it is indeed fine. You can do that. And if you skip the number of rows, the C++ compiler already understands it. It counts the number of rows by itself. As you can see in this case, it will count that the number of rows are 4 by itself. And we can also see there are 4 rows in this example. Okay, so what if we want to input a matrix from the user? How will you do it? Now, as I have told you before in the definition itself, it is a 2D array or 2D container. So we define it in a 2D container way. Like as you can see in this code, we have used one for loop And inside for loop, I've used another for loop and then inputted it. Now, this is a case with array. This is a two-dimensional array. The matrix which is defined in the form of 2D array. So this is one of the most common ways in which it is done. Here I represents the row number and j represents the column number. Now one question. Now I want you all to click to the Slido link, which will be given in the group itself. Okay, sorry. Don't go into Slido. This is for your own. Like this question is not on Slido. This I want you to attempt on your own. Like find the sum of diagonal elements of a square matrix. This is a question I want you to solve. Maybe in your mind currently. Like how will you approach it? Like I'll give like a minute or two. One thing I want to add on the question, you need to find the sum of the secondary diagonal also. As you can see in the image, one is a primary diagonal and another one is a secondary diagonal. But I want you to find the sum differently. Like one sum should be that of a primary diagonal and second should be that of secondary diagonal. Well, the method is easy. It's just two different variables. So are you guys able to do it? Come on, tell in chat. Say yes, no. Come on, guys. Okay. Okay, so let's go to the solution. Now this is the most common answer. Now what does it say? Like what is the like property of a diagonal element? Here I'm talking first of primary diagonal. For a primary diagonal, its special property is that its row number is equal to its column number. That is, its I, which here represents its row number, is equal to j. Now this is what I've used here. If I is equal to j, then I add it. What about secondary diagonal? Secondary diagonal special property, what is it? It's just that the sum of the row number and the column number is equal to n minus 1. What is n? N its order. What is order? Order is the number of rows or number of columns in a square matrix. So if you carefully observe any square matrix, you will observe these two properties of a diagonal. The first property is of primary diagonal, the second property is of secondary diagonal. If you put this condition, the question can be solved. The next question is what is its time complexity? You can see there's one loop, one for loop, second for loop, n into n. It's O of n square. Now the next question is the time complexity is O of n square. Like can we do better? O of n square is fine. Like is there anything like can we improve O of n square? Can we do it in shorter time? That's the question. And what is the hint? The hint is at symmetry. What is square matrix? Square matrix is symmetrical. Number of rows and number of columns are equal. Maybe we can do something with respect to that. Maybe we can use this property to reduce the time complexity. Think. I'll give you like 40 seconds or 1 minute. Come on. Okay, guys. Now, as someone has already written in the chat, we can do it in a single for loop or in O of n. How? This is the code. You can see the symmetry. Because of the symmetry, we can use a only one for loop, and in this way we can directly find the sum which we need. And this is what is used in certain questions. The question might be easy, but it relies on symmetry, and because of symmetry we will have to reduce the time complexity for certain questions. And matrix is one question in which the different types of question will give you TLE, time limit exceeded. But if you carefully observe things and go for symmetry, you can reduce the time complexity and do the question in the proper way. Okay, so basically matrices is done. Now there are many questions in the problem set. Basically nearly all the questions are related to matrices only. I want you all to solve this after the session or whenever you get time before the deadline and properly attempt them. They will enhance your knowledge, at least in matrix. I believe matrix is very scoring. Like what I mean by scoring is that you can easily do it in the contest. So yeah, let's move on to the next topic, sets. The question is, what is set? Basically, if I have to tell in one word, I'll say container. So by container, I mean it's similar to array, it's similar to vector, it's similar to maps. So basically, it sets has its own use. Like many times you have a freedom of using whatever container you want. Maybe you like arrays, maybe you like vectors. So why sets? Why are there different types of containers? So I believe every container has its own unique properties. Many a times in a question, there are certain properties or certain picky or catchy lines with which we can easily identify which container if we use, it will be easier. At the end of the session, I'll show you one question which is directly based on sets. Like if you use sets, a number of lines in the code will be very less. So why to use sets? What is its plus point? What are its advantages over other container? I would say there are 2 points. Like basically arrays are used very frequently. But what do arrays do? Like what is like why are sets different from arrays? Basically, if you input elements into the sets, it sorts it. The set sorts the things. It gives a sorted output. How does it sort? It either sorts it in ascending order or descending order. Second thing, second advantage is that it gives a unique output. It gives a unique element. Like for example, in a set, if you insert or input two elements of the which are the same, like for example, you input 4 and also 4. It won't include 4 two times in it. It will only include 4 one time. The thing is, it doesn't have a key, it doesn't have any pointer along with it. It is like the value itself represents its pointer. We can say in sets, that's how it is. So I've highlighted the word unique because that's one of the peculiar properties of sets. So whenever you think of sets, I want you to think of only two things. First is unique and second sorting. Okay. So what all data types can sets take in? So basically nearly all data types. Like by data types, I mean in general, the basic predefined. data types like int, float, char. It can take in anything. How do we define it? What is the syntax? Its syntax is as shown. First set, and then data type is required. It is a must. And this definition is similar to vector. So this is how you define. The only difference from array and set in the syntax is that in array, this is not given. Uh, the data type is should not be included in the angular brackets. It is written before only, like int val or something. So this is the syntax of set. As you can see, set int val, like the set which contains integer data types, and it's named as val. Now this is an empty set, and if we want to define it, we can give the values in braces or curly bracket. This is in general, like which is followed with nearly every container. Properties. Now I have told you two properties which are the most for sets, or which are like standing out factors or properties of sets. So the first property tells itself that it sorts, which I've already told. Second property is also what I've already told. It has unique values. Third property. Okay. Now the third property is uh, different. It states that the values in the sets are immutable. Now what does immutable mean? Now the value of the element, once we add it in the set, it cannot be uh, muted. It can be removed, or it can be another element can be added, but it cannot be modified as such. And that's why the values in the sets are immutable. The next thing, the next thing will tell you, I'll tell you that there's one function, standard template library of sets includes one function, which is insert. Now, this insert, when you use it, it has a time complexity of log n. I will tell you later that it has time complexity of log n. Now, this tells you why it has time complexity of log n, because the sets follow BST, binary search tree implementation, and hence, as you have already studied in binary search, when you insert it, it has to be of the time complexity log n. Then arranging order, the values in a set are unindexed. As I've already told, the index of an element is the value of the element itself. And hence they don't require any other pointer and any other index to identify the element. Okay, these are the basic functions. Now after this, I would give you two questions which you have to solve on Slido. After that, I will explain all these functions. I'll show you the implementation of these functions. So first, let's move on to the questions. Let's go. Okay, this is the first question. I want you to go to Slido and answer it. Come on, guys. I want you all to answer it. The link is shared once more in the WhatsApp groups. So in case you missed the link, you have it. This is a new link. Come on, guys. Only 50 people have answered. Come on. There are nearly 100, 200 people attending it. I want at least 100 people to answer the poll. Come on, guys. You can do it. It's very easy, very easy. Just remember two things which I have told you of sets. What are the two properties? Two properties which stand out. And you will easily do this question. Okay, guys. I believe many of you have answered the question. And yes, you have answered, like 73% of you have answered the correct option. You have kept into mind all the things I told you, the two properties of sets which I told you. So the answer is FG, option one. Now, the answer is pretty simple if you remember the two properties that which I told you. First is unique element, which is why G will be printed only once instead of twice. And second, F will be printed before G because ascending order is there. Like if nothing is mentioned, by default, it is ascending order. Next. This is the next question, guys. I'll release the poll now. Okay, guys, this is a new poll. Come on, answer it. This is the second question. A little bit harder, a little bit tricky also. Come on, guys. Come on, guys. Just attempt the poll. Come on. I see many of you have attempted, and indeed you have given the correct answer. Now, what do many people do wrong is that they go for the first option. That is small f first, capital F second, capital G third. But that is not the case. The correct answer is this. And how do we find out? By ASCII values, SI values. Now, these are the SI value table. Now in this we can find FG. F is 70, G is 71, and small f is 102. Now this is the ascending order which is followed, and hence the answer is capital F, capital G, small f. Many of you have answered the question correctly. Kudos to you. Well done. Let's move on. Okay, as I have told you before, I'll be showing you the implementation of all these standard functions: begin, end, size, empty. So this is how it is. This is the code. So let me explain you how did we get this output. So first of all, what we did in this code is first we defined a set of the data type char, which is character. Then I use empty function. Now obviously this is an empty set. So obviously it is true that this set is empty. So how does computer or any C++ compiler tell us that the output is true? The answer is by 1. So what is 1 signifier? You can see that the first element or the first output is 1. 1 is true, 0 is false. You have to always remember that. So 1 implies that the set is indeed empty, and we did this with the help of empty function. The second is a dot size. You can see on the same line, I've used the function size. It tells us the size of the set. If the size of the set is indeed 0, as I have not inputted any value in it. Now the next lines of the code, the next 4 lines of the code tell us about the insertion of elements in the set, like a dot insert. Now, as I have told you before, there's also an insert function which inserts a particular value into the set. And as I have told you before, the time complexity of insert is log n. Now, I told you the reason also because sets follow the BST, binary search tree implementation. The next thing in this code is I've used an iterator. Now, the iterator should go from the starting point. The starting point, that is a dot begin. I've used the begin function here, which implies the starting point of the set. Now, where from, like we know it is going from begin. Now, where should it go till? It should go till the end, which is a dot end, which I've used here, end function. And I've outputted the value. As it is a set, it will output a unique element and in ascending order. So A, B, F, G should be the output. So we are clear till 1, 0, A, B, F, G. What about 0 and 4? Now I have again used empty function. Now we know that the set already has 4 elements in it. So it is not by any chance empty. So the compiler will output 0 as it is not empty, which means it is false that it is empty. The next thing, size. What is the size now? Like what is the number of elements in the set? Now it is indeed 4 as we have already counted. So these are the basic functions which are used in the set. And actually these functions are pretty common. Like these functions are common in the set, unordered set, and multi-set. So I won't be teaching you once again because as I've told you, these are pretty common in all 3 of them. One question which is often asked, what is the time complexity of all these 4 functions? Begin, end, empty, and size. The answer is O of 1, that is constant. It is constant, just constant. Next question. Okay, we know that in sets, it gives a sorted output and it contains unique elements. What if we do not want a sorted output? I just want a unique output. Like whatever we enter, I just want unique things. I don't want to sort it in an ascending order or descending order. The answer to it is unordered sets. There's only one point which is different between unordered sets and sets. That is, in unordered sets, uh, there is no sorted output. As we can see in the name itself, unordered sets. It means unordered sets are the sets which do not give a sorted output. So it's pretty clear. So these are the differences between set and unordered sets. I've even provided you a link where you can read a lot about it. The main point of difference is the first point here in the table. Okay, and the second point is in the definition or in the syntax. Like how do you define an unordered set? The only difference is like in the syntax you use set data type and the name of the set. In unordered set, you just put unordered and just given dash as it is shown in as the last part of the unordered set. It's pretty simple. Okay, next question once again. I like sets. Let's say I like sets. I want to use sets nearly every time. And what if I do not want any unique output? Like there are always cases when I don't want any unique output. I just want to use sets. But let's say I want to sort it. I want to use sets. I want to sort it, but I do not want a unique output. I want to accept it as it is. Answer is simple, multisets. Now, here also we are pretty much clear with the name itself, multisets. Multisets, which means multiple inputs are possible of the same elements. It also means that if I output or input, let's say 3 elements of same, which are same, it will accept all 3, no problem. But the thing is, it won't sort. Sorry, it will sort things, but it won't give a unique output. Here's a definition of multisets. So what are multisets? Multisets are associative containers. as I have told you before, containers, basically containers which contain anything, just like sets, arrays, vectors, maps, multi-maps. Multisets is also an associative container, similar to set, with the exception or the only difference that multiple elements can have the same values. No problem there. Okay. With this, I've showed you how multisets work. First of all, how do we define a multisets? It's similar to set, just word multi is added to the set. Just like unordered sets, you just add unordered and one small dash. Here, you don't add dash, you just add multi. Only difference, rest everything is same. Functions are same, everything. Even the time complexity of the functions which we are using is same in the case of multisets. Okay, so here you are inserting 4f's and 1g. The order of insertion doesn't matter because anyways we are going to get a sorted output. So we got a sorted output f before g, and there are 4f's which are inserted. So 4f's are outputted. Here is the question. I want you to go on Slido again and answer the question. A slightly tricky question. Come on, guys, read the question carefully. Carefully, come on. Come on, guys, answer the poll. Come on. Just use your brains. Come on, you can do it. Guys, I want more number of people answering the poll. Come on. Till then, I'll show the attendance QR. This is the attendance QR. You can scan it. This will be the last Slido question for today. So I wish, like, I want at least 100 people of you to attempt it. Come on, guys. Guys, also scan the attendance QR code. Okay, so 60% of you have given the third option. And this time I would say the majority has given the wrong answer. And only 18% of you have given the correct answer. Okay, this indeed was a tricky question. The answer is not 3F and 1G. The answer is not FFFG. Many people make a mistake in this question. And the correct answer is actually only G. Now that's tricky. That is very tricky actually. And that's the thing with multisets. Like you erase one element, and if it has multiple repetitions, it will erase all of them. And yes, the answer is only G. So this you have to keep in mind that in multisets, in case of multisets, if you remove any element and if it has several repetitions, you will have to erase all the repetitions. Always keep that in mind. This is how multiset works. Now next question is, okay, if I erase any one element, it erases all its repetitions also. What if I only want to erase one F? In this case, I want to erase only one F. That too whichever occurs first. How to do that? Don't worry, it is possible in multisets. And this is the code. This code will give you 3F and 1G, the one which the majority of you answered. That is, it will only remove or erase only one F. Now, how do we do that? The only thing is we use an iterator or a find function. What will find function do? Find function will point towards the first F which the iterator finds in the multiset and then erase that only one element. So this is how you will like erase any one or any two. Like if you want to, let's say, erase 2F, you will use this two times. Like you will print a dot erase a dot find F twice, and then two Fs will be eliminated. In this way, you can control how many Fs you want to eliminate. So yes, multisets is indeed a tricky container as such, but if you just explore it a bit, you'll understand most of it. Okay, this is the question which I was talking about. Now I want you all to solve this question. Very easy question. Direct implementation of a container, which I have taught you. So let me read the question for you all. What the question says. Nastya owns too many arrays now, so she wants to delete the least important of them. However, she discovered that this array is magic. Nastya now knows that the array has the following properties. In 1 second, we can arbitrary, possibly negative integer to all the integers. Okay, so you can see this is a direct implementation of the sets. And in this case, like if you see this question and if you know the concept of sets, you can immediately do the question with the least possible lines in the code. And what does using least amount of lines in the code imply? Like it boosts your confidence. And however less the lines of the code are, it reduces the amount of the error which you might get in the code. So the least number of lines in the code is favorable, and knowing many concepts or easier concepts like sets does allow us to do it. So come on guys, it's very easy. I want you all to try this question. So this question, what does this do? It says that in 1 second, we can make a certain elements 0, and we want them all to be 0. And we want to do that in the fastest possible time. So in the first input, let's see the example. The input is all 1. Now we only need 1 second to make it all 0, because we will just use 1, like decrement all the elements in the array by 1. It will become 0. So we need only 1 second to do it. And the answer is, our output is 1. What if it's like 1, 2, 3? There are 3 elements in the array. What if that is the case? So in this case, no matter what we do, the minimum number of seconds will be 3. Like we can initially just reduce it by 1 or 2 or 3. Like for an example, we reduce by 1, then the first element 1 becomes 0. Then we reduce it by 2, then the second part will become 0. Like the 2 will be subtracted twice, so it will become 0. In the third case, the 3 will become 0. In this case, the understanding or the way to solve this question is that we just have to find the number of non-zero unique elements in the set, and that will give the in the of course whatever we input or container we use in. So that is basically the method to solve this question. And what is this? This is actually, we are finding number of unique elements. When unique comes to our mind, what comes to our mind? Come on, it's set. Unique sets. Unique and sorted output sets. So in this case, there's actually the sorted output doesn't make sense, because we just want to find the number of unique elements, just the size of the container. So it doesn't matter if we use either set or unordered set, because sorting is out of question here. So this is the code, the answer. Now I want you all to take 1 minute and understand this code. It's actually very easy. I believe most of you would have already answered it. Okay, so what I have done in this code, it's just I have just use a suitable container, just inputted values in the set, erased all the 0 in it, and then found the size. Done. Question done. If you do in arrays, you'll need to find number of unique elements and then find uh, the required output. If you do vectors, same. If you do maps or any other container, you'll require more lines of code. But in set, we just have to use one function, that is a dot size, and we'll get the answer. So this is how efficient it is. It is how it's a nice concept. So the more nice concept or more easier concepts you know, and if you're able to apply it, it will be very better. It will be very nice for you. So this was the last slide, guys. I'm done with today's session. It was nice working with you all. So are there any doubts? You can use the chat option. You can ask in the chat. Okay, I'll take one question. Is using sets better than using arrays and sorting if all the elements are unique? Like as you have seen in the question which I just did, If the question conditions are similar, using sets is always favorable. But this is just a type of question. So generally the use of sets is quite limited. But yeah, like you have understood in what conditions we have to use set. Thus time complexity differs between array and vector. Okay, so the time complexity is generally used for functions. So if you're talking about a particular function, then we can talk about it. But arrays and vectors are containers. So there's no thing such as time complexity of a container. Guys, if you have any more doubts, you can ask. There's still like some minutes in the session left.
And a vector. Remove an element from any index. But in stack, you can just add an element or remove only from the top. There is the difference between stack and vector. And one other question is what is a type particular sometimes it is a
Guys, any more questions? I think I have answered most of the questions relating to my part on Slido. If you have any doubt, no matter how basic, you can ask it. Ask it on Slido or you can ask here in the chat. I believe you have marked your attendance and have also cleared all your doubts. Okay, there seems to be a problem with the attendance. Guys, just uh, 1 minute. I request you all to kindly provide the feedback for this. And also about the attendance, it will be shared along with the feedback form. So no need to worry about it. Okay, guys, that's all for the session. Thank you for being with me. Okay, bye bye.